Chapter 10, Pontoons. Non-resident training course, Steelworker, Volume 2, NAVEDTRA14251. Distribution statement approved for public release. Distribution unlimited. Alright, Chapter 10, Pontoons. When the United States entered World War II, the Navy was faced for the first time with a problem landing and supplying large forces area with additional harbor facilities were controlled by enemy. Navy lightered platoons, or NL, were developed in 1942 to meet the difficult situation. They were designed to erection by Navy personnel shipping aboard Navy vessels. These pontoons proved to be an invaluable asset and were used extensively in operations during World War II, the Korean conflict against Vietnam. The P-Series pontoons. P-Series pontoons were used throughout the Republic of Vietnam in combat conditions, although originally designed to meet the account requirements for the advanced base functional component systems. They have been used successfully in many other fields due to the inherent versatility, easy of erection. Large structures are easily quickly disassembled, then made into smaller structures, and then the smaller structures quickly, easily be reassembled. The larger structures, light draft, structural strength, mobility, adaptability, pontoon structures made them extremely useful. Shallow water passage, tactical development in Mekong Delta. They allowed movement of heavy weapon shifting firepower throughout the otherwise remote areas. Many structures not discussed in this manual, such as armed barges, helicopter pads, mortar barges, barracks barges, were constructed in the field for use in special situations throughout the waterways of South Vietnam. Types of P-Series pontoons. 5 basic P-Series pontoons are used in today: P1, P2, P3, P4, P5. These pontoons, specially designed, internally reinforced welded steel cubes. They are tested with an internal pressure of 20 pounds per square inch. All pontoons have been plain deck plates covered with a non-skid coating that are all fitting in a 2-inch plugged hole air drain and siphon connections at the top of the bottom of one end points. The P1 pontoon is a cubicle in shape. See Figure 10.1. The deck of the P1 is 5 foot 3 1/8 of an inch by 7 foot. Sides of 5 foot 3 1/8 of an inch high. Side end deck at the bottom plating is 3/16 of an inch. The P1, most common, widely used pontoon in P-Series, is usage required every structure pontoon system. P2 pontoon has the same depth of 5 foot 3 1/8 of an inch as the P1, but is 7 feet square deck, straight line, sloping bow. See Figure 10.2. The side end and the deck plates are 3/16 length, so the sloping bow plate is 3/8 of an inch thick. The P2 pontoons are used on bow and stern various pontoon structures. So 10.1 shows the P1 pontoon. P2 Figure 10.2 shows the P2 straight line sloping bottom pontoon. Alright, the P3 pontoon has an inclined deck at 5 foot 1 3/4 of an inch length and 7 foot wide. The deck slopes to 4 foot 11 3/8 of an inch, either 3 foot 8 1/4 inch. Bottom is horizontal, plating at 3/16 of an inch. Sloping deck is fitted with 1 inch square ribs, 5/16 long, evenly spaced, secured by welding with a covering of the non-skid paint applied between the cleats. The P3 is used in conjunction with a P4 to form a gradual slope ramp for causeways, ends, ramp barge bows. The P4 pontoon has a deck of 5 foot 1 3/4 of an inch long and 7 foot wide, inclined same angle with a P3 pontoon. The after end of the 3 foot 6 inches high for the end, 1 foot bottom, and the horizontal 8 inches on the after end, and the sloped upward to deck side and back plates of 3/16 of an inch thick. Bottom and bilge of the plate of 3/8 of an inch thick. Finally, 5 evenly spaced 1 inch square ribs are welded to the sloped deck and coated non-skid paint applied between the cleats. Used in conjunction with a P3 pontoon. P4 forms continuous ramp for causeway ends and ramp bar bows. Figure 10.3 shows the P3 slope deck pontoon. Figure 10.4 shows the P4 rammed end pontoon. Or the P5 pontoons consist of the P2 pontoons with the quick lock hinge connectors fixed to the bow. The P5M is the P5 with a male connector. The P5F is the P5 with the F field with a female connector. See Figure 10.5. The P-Series 3 by 15 pontoons causeway are connected end to end by an alternate P5M P5 P5F pontoon so barred sections or waivers where the end-to-end connection is required. Pontoons are constructed welded hinge for the P2 pontoons, then assembled in the male-female sequence, forming causeways of any required length. The pontoons are always used in enlarging, extending war structure. Center section of the P5F hinge is made of the section extra strong pipe when joined with the two parts, resisting torsion, compression, vertical shear force of the joint. Making end-to-end connection of P5M male and female pontoons not a difficult task. When mating ends for the two causeway wharf sections are brought together, the male pipe connecting is simply guided into the female and held in place with the pad eyes and vertical and links. Resolving pipe that prevents vertical movement at either section. Short chain and lock device and completes the connection and secures the links and the pad eyes. Each hinge is capable of withstanding 300,000 pounds of pull. Closure plates are welded on either side, each for the connection of the bridge, owing a space between the pontoons. A wide variety of structures, waivers, barges, causeways, and so on. Assemble the pontoon. They assemble the pontoon struck with the pontoons firstly joined and strings are lodged. Floating strings are then attached to each of the structures, not over 3 strings width, can be entirely assembled on the land. Then launch as unit. The number of the pontoons is each string, with the number of strings attached to each of them depends upon the size, type of the structure being assembled. Manner of assembly is similar in each case, with a variation depending largely on the intended use of the completed structure. The size of each pontoon structure is assigned by indicating number of strings. Assembly with the number of pontoons each string. There are 3 by 15 causeway sections and 3 string wide 15 pontoons long. Pontoon gear is usually shipped with parts required to complete the specific structure. Pontoon attachments. Pontoon attachments used in basic assembly pontoon structures, including assembly hinge, bolt, nuts, keepers, assembly plates, and closures. 10 and 5 shows the end-to-end connection of P5 male and P5 female pontoons. The male is on the bottom, the female is on the top. Shows the pad closure, assembly pad closure, assembly pad P5 pad eye assemblies, link assembly, connection assembly. Structural seal assembly angle of vary length with the U of the connection PC pair and tune with the strings. Each of those assemble the definite number of pontoons designated with the E series angle with the angles of position at each of the 4 ends of the row. Pontoons various type of the assembly angles are available in Figure 10.6. Shows the ES16 assembly in Figure 10.7 shows the E assembly angle of the E16L and E16L and 26L. Angles are supplied in several lengths of the strings can be made with a minimum number of weld joints. Designs with these welds fall the midway along the edge of each pontoon rather than between the pontoons where stress is greatest. Each angle is 1 or 2 cross-sectional size, 6 inches by 6 inches by 1.5 inch thick by 8 inch or by 8 inches by 8 inches by 1.5 inch thick. Angles with 8 legs are used to replace 6 by 6. And the center strings are 18 by 24 pontoons long. String of 30 pontoons have an 8-inch angle throughout to resist the extra stress that from their weight imposes. Regardless of the dimension, however, the PC angle would fall into one of 2 types: basic end condition angles. Basic or end condition angles. Basic angles are those angles used throughout the body of the structure. Their application is not restricted to the top, bottom, left, or right. Figure 10.6 of the E1516 assembly angle and assembly angles E16L and 26 in Figure 10.7. Angles of strings, on the other hand, end conditions, angle of the P2, 3, and 4 pontoons, and with the strings each designated specific orientation, top and bottom, right and left. Basic angles are shortened or lengthened to make up the modified configuration. End condition angle that can be cut formed by basic angles to meet abnormal requirements. The A6B assembly bolt is 1.5 inch diameter by 3 and 3/8 inch long hexagonal head with a steel bolt. 3 radial grooves, head and space 120 degrees apart, are the coated grade 5 steel rated with a tensile strength of 105,000 pounds psi. In addition to using the securing assembly angle of the pontoon, each corner of the A6B bolt is used with the connection of strings into structure, secure deck fittings and accessories, and pin hinges, dry dock stabilizer towers. A forged FN1 flange nut in Figure 10.9 designed to fit into the pontoon pocket sufficient clearance to allow position of the A6B assembly bolt. Flange nut is large enough to prevent the nut from turning in the pocket when the bolt is tightened and formed near the midline of the nut. Clear welds in the pocket allow positive setting of the nut boss between the A6B bolt is tight. 10H of the A6B assembly bolt. Figure 10H of the F91 flange nut. The KP1 keeper plate is made with a plate of a 3 3/4 inch long by 2 1/8 of an inch wide by 3/16 thick. And the plate is cut out to fit over the floor of the hexagonal flats A6B with a bolt head. Ever finally tighten the bolt and the pontoon strip of the keeper plate is positioned around the bolt head skip welded to the underlying assembly plate at an angle that prevents the bolt from working loose during operation. Reduce maintenance problems. You should use the keeper plate on the bottom of the pontoon structures where daily inspection is impractical. Keeper plate should not be welded to the bolt head. Steel plates of various shapes are used in assembly with the pontoon structures, mostly in reinforcing the areas suspected with a maximum stress here. A number of different types of assembly plates are shown in Figure 1011. Each of the plates are shown with a designated with a specific application indicated below. The AP1 connection plate. AP1 is the steel plate with a 4 drilled hole for the A6B with assembly bolts to reinforce the A6B bolts. The old pontoon strings to each of the completed structure of the either 6-inch or 8-inch angles. The AP3 launching angle plate when pontoon structures should be side lobe. The LST accessories known as the LA1 launching angle and attached. The AP3 is a steel plate used to attach the LA1 structure. The AP3 has 4 drilled holes. The A6B bolts and covered plate is attached with a semi-cylindrical pad. The pad serves as a fender to protect the hull with the LST on which the pontoon structure is side loaded. 10/10 of the KP1 keeper plate being installed on the A6B bolt. Alright, so we have the AP1 connection plate, end plate, AP1 angle plate, AP shafting plate, AP4 tie plate, AP7 gasket plate, L2 launching angle and end plate, and the AP5 ramp and bent plate. Note, as putting the LST there, beginning with the decommissioned undecided platform transport causeway, the information LST is given because of the reserve fleet will retain 2 of the next platform which require the hardware for the loading and launching. The AP4 tie plate is a steel plate with a 2 drill with the A6B holes through with a connection pontoon string with each of the other with the bow and stem ends the necessary with acceptable substitute. AP4 can be obtained by cutting the AP1 connection plate half across the narrow dimension. 2 plates are produced for both. Will you use LA2 launch angle and the LA1 launching angle with the self-loading pontoon structure. LST is attached structure bow and stem ends 2-hole assembly plate. Just as the pontoon shrimp with connected with the structure of the 2-hole AP4A with the bow and the stem of the 2 drill with the LA2 with the A6B bolts. 2 half-oval well with the perpendicular upper face of the plate and on either side of the bolt. These half-oval lugs serve as a fender to protect the hull of the LST in the same way with the pad AP3. The AP5 end plate with the AP5 steel plate with a welded across the gap between the pontoon with the bow and the stem of the adjacent string to be used only in certain special cases where structures require extra reinforcement. For example, where the end connectors are used to wear the structure well-sided launch. Show the typical fender installation, the RFE bracket, the wing-type rubber fender, the hex nut and the retainer, and then show the fender corner bends with the RFN welded ends form 90-degree angle. The RF4 drop fender used on ends, the trim flanges, fender mounting horizontal, vertical, and diagonal. Except the substitute of the AP5 can be field fabricated as necessary for the AP1 to do so. Remove the holes AP1 by cutting 3 inches inside the 2 edges of the 18 1/4 half. The result of the 18 1/4 by 5 inches plate will produce a 9 1/8 of an inch by 5 plates. Both can be used as plates. The AP6 shafting plate, AP6 shafting steel plate, 10-inch square with 2 opposite edges beveled, welded to the other side. Causeway section AP6 protects causeway with a damaged sliding contact. It's frequently used between the side lap causeway sections because AP6 non-stock items should be fabricated with the field when required. Dimensions are not critical. Have the AP1 or AP7 plate will serve the chafing plates were properly beveled. The AP7 gasket plate, AP7 gasket plate, steel form on a 9 inches high trapezoid parallel the area. Edges 18 inches and 12 inches long with the 18-inch edge at a 1/4 inch bevel. The AP7 reinforce the end condition angle with the 4 and end of the large structure for the 18-inch of the edge position against the tip of the bottom of the angles plates. Bridges the gap between the pontoons, which angle is both the 18-inch edge of the welded to the angle. The 2 vertical edges are welded adjacent pontoons. The AP1 connection plates can also be either reinforcing welded to the end condition angle, same plate with the AP7. The AP8 Ramp end bend plate, the AP8 and fabricated steel plate 11 inches by 20 and a quarter, rectangular bent for the two legs 8 and 5/8 of an inch over the 11 and 5/8 of an inch long. Each leg has 2 drilled holes. The A6B bolt with the AP8 using the connection pontoon strings over the point where each string with a P3 slope deck ramp or dunes connected in P1 pontoon. Rubber fenders. A new rubber fendering system is found on the use of the pontoon structures. Replace the oak and timber the fender with the rubber fendering wing type. The extrusion shape of the steering to build butane composition supplied with a random length of the cut formed and fitted with the fill with the specific structure operation conditions. Structure fender brackets from retainers, fasteners are furnished in quantities required by the new fenders to absorb enough impact under the contact with the dock and the other structure to transfer shock. Dynamic static load, thereby protecting the improper structures. Two steel rubber fenders that lay out with the fender deck over the position, install the cut it into the required bolt length with the bolt of the retainer bracket for the ease of the position using the line attached tack weld brackets placed with the temporary removal of the lines. Entire fender is properly positioned, weld all brackets shown. Drawing damaged portions cut out with a repaired rubber portion of the same length. Use the odd piece of the drop fenders or bumpers. Use a fine-tooth oil lubricated saw, manually operated power operated cutting wood or steel bits from the drilling holes, various fending arrangements. Details shown in Figure 912. They are subject to change to meet all fendering needs. H6 hatch covered in floor assembly. Various pontoon structures require storage over the plates for the tool chain fitting to the miscellaneous gear with the nut and use the H6 hatch cover the floor of the panel assembly. Figure 1013 designed to install any designated pontoon structure and consists of mounting frames, grating, panels, hangers, rings, and 20-inch diameter quick-acting waterproof flush mounting shipboard type scuttle together with the parts required to convert a P1 pontoon into the storage compartment. Making necessary cutout in the pontoon deck and some of the hatch cover. The other components are done in the field with the install of the hatch cover to string in the pontoon deck. However, the structure normally transversed by heavy load such causeways, ramp, barges. It's advisable to locate the hatch cover away from the regular line travel, preferably to one side as far forward and after as possible to protect the watertight sealing gasket of the hatch rim. Deck closures are used the bridge openings and slots between pontoons while meeting them. Alright, show the hatch cover, the 5/16 23 and 5/8 of an inch 16 supporting frame. Shows the hatch cover of floor plan assembly, intermediate and deck plan, large deck panels, small deck panels. Requirements fitting around the plate lift pads that can also be configured to provide access for the assembly angle between the structure wrapping chain with the wire rope during the cause of the beaching. The LSU side carrying operation, formally 5 type of the closure needed to perform necessary function. Identify the DC1 through DC5, D6C construction deck closure. Will certain field with the alteration designed to fulfill all closure requirements. Will play with the 5 closure entirely stocked with the heaven and pleated. The H22 and H23 closure plate with the joining pontoons making the bridge from the wharf, the barge to wharf connection. The H17 and the aft, male and female. Heavy duty fittings used with the deck outputtings. The form between the pontoon structure for the closures are in Figure 1015, which are 20 inches wide by 24 and a quarter inches long and made with a 1.5 inch steel plate, or even the combination fit over the enclosed heavy-duty hinges. Non-skid coating applied with the top of the closure prevents slippage. The H22 and 23 closures are not included in heavy-duty hinge set, but they are fabricated in the field as required. Bits and cleats are steel posts, though, arms to which they have lines of secured structurals or side carried and should have the bits as well as the deck fittings. DC deck closure. 1015 closure plates, H22, 23, pontoon 1, pontoon 2. Bolted down on the launch angle slab of the typical cleat is shown in Figure 1016. The B1 all-purpose bit consists of a single 4-inch diameter post with a 3/8 inch, 13 inches long with a 6-inch diameter cap welded to the base. Has 2 drilled holes. The A6B with assembly bolts, 1.5 inch diameter crossarm, 16.5 inch long runs of the post, approximately 10 inch above the deck. B1 can be used as all structures requiring single bit, but can be welded to deck angles opposite of the launching angle side. The B4 bit is the same as the B1 bit, except that the base has been designated as a quick position with a CP1 chain plate. Alright, so 1016 shows the cleat, 1017 shows the B1 all-purpose bit, then 18 shows the B4 retractable bit. The M4147 double bit consists of 8 inches steel pipe, consists of 20 inches long welded 13 40-inch base compact to the upper ends. Propulsion unit. Self-propulsion pontoon barges, tugs, and the power of the outboard propulsion unit. These units have been specially designed for the purpose of readily installed with tug and barges of any size. Propulsion unit shown figure 1020, especially with a heavy-duty outboard motor consisting of propulsion mechanism, marine diesel engine mounted on heavy structural base. Proposal power is carried for the engine through the right angle housing as vertical drive housing to the propeller, steering the effective of the shifting the propulsion force direction. Propellers can be turned against the vertical axis in either direction for the complete circle. Each of the unit has a steering wheel and an indicator showing the direction travel. Tail section properly mounted with a vertical housing assembly that can be elevated back, forward, or outward and backward to raise out of the water inspection with the repairs. As new equipment and technique for the amphibious operation developed, the performance requirements for all of the components increased accordingly with the role of the propulsion unit to increase the power thrust capability. 1019 show for the M147 bit, 1020 show for the Metal 295 diesel engine outboard propulsion unit. Pontoon string assembly. After the two assembly angles have been placed on the wave of the pontoons are placed with the angle of figure 1021, figure 1021, 22, with the pontoons are positioned on the sides of all the deck surface the same size. First pontoon orderly be placed in center of the angles with the assembly bolts for the line with the placement of the remaining pontoons from the center toward each for the end of the can be accomplished without difficulty. Bolting lower angles. Each position is placed with the assembly angle of the A6B with the assembly bolt hole with the pontoon nut with the receptacle line. Those angles with using spot wrenches, drift pins necessary. A6 bolts are then inserted in through the assembly angles. 1021 show the pontoon position on the assembly. Figure 1022 show the play one pontoons assemble the angles and start with a hand to thread and female FN1 nut. Bolts should be snugly tightened backed off the one turn position. Upper angle, the second pair of the assembly angle placed on the top of the pontoon position, bottom bolted. 1023 show the A6B1 bolt and F91 nut connecting pontoon the assembly angle. The same man with the bottom of the pair of the angle spreader jacks coming along with a heavy duty pinch bar that can be the line angle of the top angle with the tighten bolts all after A61B assemblies have been installed with the final tightening accomplished with an impact wrench 48-inch ratchet wrench and the location accessory assembly plates and not bolted to the structure. Note the proper setting of the A6B bolts requires tightening of the 2,400 pound foot torque. The applicable rules to draw the bolt not up too tight and then add another half turn. Final assembly string the CP1 chain plates, LA1 launch angles over the accessory attached outer edge of the particular structure under construction can be installed with the string at any time. If the desired string is required, additional launching angle should be assembled in a way with the launching angle be initiated at the top of the string. After the installation of the chain plates, A6B assembly bolts then attached to the part. Tighten with the chain plates or over the other accessories of the items be welded. Required a KP1 keeper to play with the install at the time and location with the specified with the one string with the structure being built. After fittings in the place with the assembly bolt tighten, assembly should be inspected for the security of the bolt and fittings. Half of the trail string have been launched. Time with assembly proceed with the valve with assembly with a check with the additional string with the applicable. Launching a string with the pontoon string that has been assembled along with the edge of the deck with the mid-tilt with the water removed with the jacks for the crane has been assembled up away with the anchorage of relief. The string is allowed the glide on ahead of the water. Note with the adequate freeboard required with the method of launching. Each launching can be accomplished on flat, nearly flat ways, pushing the string within the bulldozer or pulling it into with a tug with the M-boat string and also has been assembled inland and pulled into the shoreline by a bulldozer line secured with the string with the before launching should be made fast on shore to keep the string from the drifting away on either side of launching. Ends of each line can be assured that the strings rights itself as when launch. Assembly of launch string structures. New method securing pontoon structure to refer to the bolt and nut attachment implemented through the pontoon system. Completely replaces heavy tie rod assembly further and consists of the A6B with a heavy nut connection with the holes in its vertical level the joining assembly angle between the strings. Special wrenches has designed to facilitate the bilge angle connection with working with the deck from the deck. Two-piece aligning tool which gives the whole alignment of restored capacity of the bolt. Detailed instruction for the using bolt knot method and connecting assembly pontoon structures are presented below. Figure 1020 shows the angle clamp assembly pontoon strings and assembly angles in the JT clamp. Two clamp. Figure 1025 shows low angle and details of using bolt nut connections inside tie rods. Whole bag wrench, drive wrench, lanyards, assembly A5B, bolt hex nut, AEC2 angle, waterline assembly angle, universal joint, ratchet wrench. At each pontoon string, the launcher is brought alongside of the other string with the lined up to clamp together with the J2 angle clamps. Insert the A6B bolt with the by hand through the bolts on the vertical leg with the top of some of the located in the space between the pontoons. Screw them with a heavy bolt nuts. This is done in every space of the string with the middle with the working together. Each end of the connections are thread snug only with it this time with the tightened later. At the top of the bolt nuts and then plate for the bottom of the angle connection. Start with the hole of the location bolting pattern. Same with the two angles of the exit with the special wrench are used for inserting bolt holding nut tightening, which is accomplished with the deck side. Using JT7 the drive wrench instead of the A6B bolt with the holes with the joining bottom angle with the main contact with the nut being held in the position. The JT8 backup wrench with the thread contact has been made, drawing up snug with the do not tighten until all the bottom bolts have been installed. Again, work from the center of the both ends. If only one special wrench is set, use the start and center work on each side alternately towards the end. With all bolt have been installed, reverse of the wrenches on the JT8 holds bolt. With the JT7 the drive units and tighten all of the nuts and bolts at the top and the bottom with the required torque 2,400 foot-pounds. Though the applicable rule of the draw nut tie up and tight and then turn it about another half turn, see figure 1025. JT13 is a two-piece angling aligning tool. Should be even the difference of hole alignment between angle restricts easy passage of the A6B bolts. The JT13 inserted anywhere along the strings, preferably in the center, drawn together using the JT7 and JT8 drive with the backup wrench to leave the aligning tool on. Install will remove the JT7 and JT8 wrenches. Complete connection of the bolt and nuts, after which the remove of the aligning tool replace the bolt and nut lanyard rings provided with the wrench. The two-piece aligning tools must always be safeguarded against loss. Each string that screw the bolt and nut with the preceding string with the install of the AP4A plate with the pad. Each clock sheets otherwise accessory with the required to strip the non-previously installed the strings are welded the bolts in position, spring the detailed drawing. Complete the assembly, skip weld the deck closure of the slots for the deck. Assembly of the complete structural land. Assembly of the complete structure of the land is beginning with the same with the construct of the string, with except for the structure assembled of parallel the shoreline rail, perpendicular to the shore structures of the string of the belt, and the man with the assemble the second and third strings on the top of the first. When built this way, the bolt nut attachment previously described assembly plates are installed with the work process. The KP1 keeper plates well with the bottom of the A6B assembly nuts bolts and access for the bolt nut interfere with the launcher can be attached with the assembled portable scaffold fabricated in the field. Similar to the shown figure 1026 attached with the pontoon assembly, but the angles can be moved at the other locations on the structure to meet construction progress. The completed structure can be side launched and sliding it out at the end of the rail, tipping it into the water. Using pontoons assembly, a barge and several pontoon string with assemblies connected together to form a complete unit of the transport cargo. Include vehicle with a person on the duty primarily with the transfer loading craft to amphibious vehicle to lighter age duties and ship to shore movement of the cargo barge design lighter operation. Either the self-propelled or towed can be built on various sides and with modifications required can be either the driving plate with the salvage operation as the tugboat and gate vessels and fuel storage of the mounting cranes. The intended use of the large strand determines the length of the string, the number of the strings needed with the pontoon configuration. Each string, except the standard side of the barge or P-series equipment is included. Alright, show the 1026 shows the portable scaffolding assembly structures in the pier. Following 3x7, 3x12, 4x7, 4x12, 5x12, 6x18, and 10x30 barges. Conventional pontoon barge is sized up to including the 16 barge is designed to carry its own rated load of 1 foot. Freeboard on load, concentrated center point over the heavy enough to bring in a deck wash. 3x7 pontoon barge, general purpose structure used necessary for the lighter for the ferrying operation, carriage transport can be accomplished over the barge. Can be self-propelled by mounting propulsion unit on the end without fender of the 3/7 barge with a propulsion unit is shown figure 1027. The 3x12 pontoon ram barges ordinarily used with the transporting cargo. The equipment that have proved the suitable general amphibious operation shown in the bone of the ram attached permanent beaching barge under its own power. They also help with the unload tractor of the equipment that will use in assisting forming a causeway pier. Figure 312 barge can be slided on the LTST with the side carry of the assault area of the barge can be loaded in the well deck. The LST with the load deck loaded on the LST. The 4/7 pontoon barge is similar to all aspects of the 3/7 barge except with one string wider, although for the general purpose of the barge with its principal lighter alterations is suitable for any transport risk within its capacity. Figure 1027 of the 3x7 pontoon barge propulsion unit. 4x12 pontoon barge is general purpose structure that can be used with the lightage over the operation of the towing and self-propelled storage with added propulsion. 512 pontoon barge, one string wider than 4-foot 4x12 barge, but in still in all respects particularly suitable for the mounting crawl crane. Lifting capacity ranging from 20 tons to 12-foot radius with a 7-ton 55-foot. Barge can also be used with the general purpose structure. Can be used in lighter age operation self-propelled structure by additional propulsion units. 618 pontoon barge is the second largest barge of the P series of the pontoon installation propulsion units can permit the lighter age operation transport load cargo vehicles personnel up to 25 tons. By the addition of the accessory of the equipment on the barge converted with the 1,500 barge fuel storage barge. Also installed heavy-duty hinges barge can be converted with a raft with outfitting repair with a small structure when placed in the deck. Alright, the 1030 pontoon barge is the largest barge in pontoon system developed primarily for the mounting a 100-ton derrick. Barge, however, the adaptable to the other use of propulsion was the units attached to conserve the lighter age barge in transporting 800 tons cargo and one time from the ship to shore or dock. Barge can also be figure 1028 of the 1,500 barrels 6x8 fuel storage barge used in piers, wharves, and install heavy hinges connected with the existing pontoon wharf and enlarge extent of the structure. Essentially, tugs or barges equipped with the outboard propulsion with accessory equipped with operation perform P-series with the equipment. Tugs widely adaptable can be used with the towing cost standing with the placing and retrieving. Figure 1029 for the 100-foot ton derrick mounted 10x30 barge. Anchors help with the operations if the installation will cover the fuel system of the 3x4 warping tug shown in figure 1030. Equipped with the two outboard propulsion with the after end single string center string with the incorporates anchor the housing accommodate 2,500-pound mooring anchor. Also, the anchor wire away from the propulsion screw with an A-frame is mounted on the boat with a tug with a stand with approximately 13 feet above the deck of the barge. The double drum is mounted near the stern of the barge. Line after the drum and the fairhead laid to the deck on the back of the anchor and stern. While the line is formed, a drum and run over the sheave at the top of the A-frame, and the sheave is lifting over the bow, pulling the bow over the warping and the tug. The winch is mounted with a welded steel cross brace frame. Standard equipment for the tug includes the M147 double bits, navigation lights, warping tug approximately 9 foot long, 21 foot wide, and a steam draft of 48 inches, bow draft 18 inches in speed. 6.5 knots, 3x1/4 inch warping tug replaces 3x12 tug through the pontoon system. The only difference in the two is that the 3x14 tug is longer than two P1 pontoons, incorporates new style winches with lines feeding off the horizontal laid drums. Alright, 1030 shows the 3x14 warping tug. A pontoon causeway consists of the inshore of the offshore section, many intermediate sections necessary to make up the desired length of the up to 1 mile considered possible. Each section is 3x15 structure. The design of the structure is a load at 105-ton freeboarded 12-inch. Each string offshore inshore section is made up of 12 P1 pontoons or with a P3 slope deck pontoon, P4 ramp end pontoon, one end to the other end of the end-to-end connection pontoon, P5 female connection to the offshore P5 male end connection pontoon inshore section. Strings of the intermediate section figure 1033 is made up of 13 P1 pontoons, P5 and with a P5 female one end and P5 male at the other. Single loaded causeways as well with the barge binges are transported to combat area of the LST to facilitate. You should weld the hinge rail with the shelf of the bracket at each at the LST. The A1 launching angle is both the one on the outboard string of the barge and causeway. The LST listed far enough to the side being loaded. Permit hinge bar pontoon structure to be hoisted up the shelf bracket. The structure hoisted upright either by crane or by winches. On the LST, the hoisting sequence vary depending on the gear of the LST involved. Regarding the message of the personnel of the Amphibious Construction Battalion, usually with the SB, BMC with the charge of the bringing they require gear aboard to do for the job of the ship. The company make with the necessary precautions aboard ship, provide whatever assistance required of them. Floating dry docks. Floating principal dry dock construction consists of the principal of the man's wharfing like deck with the vertical side of the towers construct with a piece here with the pontoon with the unit with the piece pontoons dry deck submerged with the spinning in a bit. Emitting the control of the amount of water with the deck pontoon, the rate with the expect with the water with the compressor with the tower pontoon tack. Stabilizer, keeping the drive at the dock level of the deck is done with a wave of the dry docks required 8-foot water to be submerged with the decks at 12 inches maximum. Safe submersion shall be moored sheltered quiet water 18 to 20 foot deep in an area with a smooth bottom to avoid large rocks, other obstacles. Two-size pontoon dry docks are present with the ABFC system identified with the 4x15 100-ton capacity dry dock and show the 6x30 pontoon dry dock installation. Some of these are made with erecting pontoon strings with the dry dock, same that use the other pontoon structures. Only P1 pontoons are used. And this shows a figure 10 runs through the offshore causeway section. Figure 132 shows the offshore causeway section. See detail A and B. Figure 1033 show the intermediate causeway sections. Remove filters in from the C1 cleats. Remove J-hooks from one end of the LA1 bracket attaching. Alright, 1034 shows the LA1 launching angle, pontoon plate, pontoon, AP1 LSD shelf bracket section, view hull, and seam. 1035 shows a 6x30 400-ton pontoon dry dock. Are made of the upstream of the launch, joined with the water, same as the other structure have with the before pontoon shrink and instruction dry dock drawing should be made, prepared details show with the type, the location, part, together field erection information important, make available the applicable dry docks to be erected at all times during the little initial store instruction storage. Ensure the main parts are properly located, positioned, secure with the facility erection during the final storage. Elevated causeway section. Elevated causeway pier facility provided with link between the litter edge of the beach for the bridging and surface zone on the standard LE. Elevated causeway pier facility consists of 6 3x15 approach roadway sections, 6 3x15 pier headed section, pier headed 2 section wide by 3 sections long. Since the facility is modular, expand with enlarging pier headed, adding the approach to the section. The basic components of the ELCAS is 3x15 intermediate causeway section covered to elevating mode of additional spud well. The spud wells provide with the attachment between the causeway deck, the supporting piling, internal spud wells. Figure 1037 U with the full width of the causeway section required for the traffic. Support fender piles along with the fender size of the pier head. The internal spud wells incorporate 4 groove connection pins. They are inserted in 4 rectifier boxes attached to the side of the causeway. 2 guillotines are lowered into the pin grooves behind the receiver of the boxes to secure the spud well to the section. Steel angled locking key is used to lock the guillotine into place. External spud wells are shown in figure 1038. Alright, shows 1036 show the 12 section of the elevated causeway, roadways, beach ramp, internal spud wells, turntable, fender section, external spud wells. Figure 1037 internal spud wells, bolt holes for pins, pad eye, compensator, and frame. Figure 1038 external spud wells, connection pin, key, guillotine, and pad eyes. Are used the outboard string pin head section where sided inside a section, another section required load bearing, such under the condition. Container head crane, external spud well, fabricated frame having the same overall dimensions of P1 pontoon is interchangeable with. Alright, figure 1039 type of the position causeway with the ELECS. Show the inshore intermediate section approach, intermediate section, pier head section type 3, pier end section type 1, 2, and turntable section 1, type 1, pier head section type 3, pier head crane section type 4. P1 pontoon used this acting hardware. The ELCAS consists of 4 distinct parts of trawls. The pier head unit made up of 4 type section offshore of the ELCAS support cargo unloading function. Pier head include the cargo insulation offloading lighter age Turntable for turning trucks around on the causeway. Fender section provided with an interface with a pier head. Lighter age. Roadway provides two-way traffic between Pinhead and Beach. Beach map provides a way access for the ELCAS. And type section used in location figure 1039. Crosshead section. Pier head type 1 pier head section makes use of the 4 internal spud weld sections equal with the support brackets to receive side connections used in these side sections side by side of the 3 pinhead connections. Type 2 pier head section consists of 6 internal spud weld support bracket side connectors, and always you do this type of additional type 2 section contains 6 reinforced P1 pontoons. Type 3 pier head section use the 4 internal and 3 external spud weld support brackets must be also added to the support add side connectors. ELCA fender system show the spud weld, cannon fender, foam filled fender, rigging fender, impact bumper, 1 by 15-inch string. Typical type 4 pier head section will support with a container handling crane contains internal 3 external spud welds, 6 reinforced P1 pontoons are included. Alright, construction of a fender section 1 foot by 15 structure incorporates fender spud weld figure 1040. Fender piles are driven in the fender spud welds after the causeway clearly elevated. 1041 fender section can rise and fall in the piling sires. The foam filled fender strung on the outboard side of the fender system was over the impact of lighter 8 since only 1 pontoon wide. The fender system is P5 pontoons end connection installed in P8. Figure 1041 ELCAS fender system W and lighter morning pier headed section elevation. Fender pails, fender corner fender, 1 by 15-inch fender spud, and an impact bumper. Chapter 11 Pre-engineered structural short airfield tactical support.